The second type of hydrolysis then is the alkaline hydrolysis, where instead of using water, we're using sodium hydroxide. Now, you would expect the sodium hydroxide to be on here and have our water there. However, it's not as straightforward as the acid hydrolysis, which I'm going to go back onto the other screen to kind of show you how all this works. So the way to think of it really is almost as if it's a two-step process. So whether it's acid or alkaline hydrolysis, just keep remembering that all we need to do is cut that bond there, and we need to put water back into it. So let's put my plus water over here. So I'm going to put my water back into those. So when I put my water back into those, I recover my carboxylic acid, so CH3, CO, OH, and I also get my alcohol as well, which is going to be HOCH3. And of course that's exactly what we were doing when we were doing the acid hydrolysis. The thing is that what we've got in this mixture acting as a catalyst is sodium hydroxide. And the sodium hydroxide, if you remember the acidic nature, can actually react with that. So what we get really is a kind of second reaction going on after we've done the hydrolysis reaction. And that second reaction is this, that the carboxylic acid that is formed after the hydrolysis of the ester now reacts with the catalyst, which gives us that and water. Okay, so we get sodium ethanoate and water that is formed. Okay, so there's two steps here. So there's step one, which is the hydrolysis, which gives me the carboxylic acid and the alcohol. And then there is step two, which is the carboxylic acid here reacting with the catalyst, the sodium hydroxide. Now, what's interesting here is when you put those two reactions together. So let me clear all this out, and we'll put the two reactions together without me scribbling all over them. And then we'll do that thing that we do where we just add the two reactions together to see what we get. Okay, so remember in the first instance then we've got CH3, CO, O, CH3 plus water, which is going to give me my carboxylic acid and alcohol. Remember, that is step one. So step one is the hydrolysis. Step two then is the carboxylic acid that is formed at the end of step one, reacts with the sodium hydroxide to form sodium ethanoate and water. And what I'm going to do now is I'm going to add the two reactions together and cross out anything that is the same on both sides. And I hope what you can see here is I've got water on the left and on the right, and I've also got my carboxylic acid on the left and on the right, which means what I'm left with now is the ester reacting with sodium hydroxide, and this is why we put the sodium hydroxide in the reaction rather than on the arrow, because it catalyses first, then reacts with the carboxylic acid afterwards, which then forms, rather than the carboxylic acid, it forms the salt of the carboxylic acid, so in this case sodium ethanoate, and we also get the alcohol over here, okay? So when you're doing these, when you're doing the alkaline hydrolysis, the best thing I can say to you is hydrolyse it as normal, but then have a look at your carboxylic acid and then turn it into the salt of the carboxylic acid. So if you go back to the notes here, in the alkaline hydrolysis, remember what we do, we cut it there, all right? So in my head, this is what's going on. So in my head, I'm doing that, okay, and I've got my alcohol that I've got there, but because I've got sodium hydroxide here, what I'm now going to do is I'm going to get rid of that, and I'm going to put the Na in its place because it's the alkaline hydrolysis. Okay, just have a look at a specific example here then. So we've got ethyl propanoate, so cut it along there, all right? Again, the thinking in my head, so it's with sodium hydroxide, so the thinking in my head is CH3, CH2, COOH plus the alcohol. And then what I need to remember is that because it is the alkaline hydrolysis, I'm going to get rid of the hydrogen and I'm going to put the sodium in its place. So it makes sodium propanoate and ethanol. You can, if you think about it, remove the spectator ions. And if I kind of just cross out on this reaction the spectator ions, the sodium here is a spectator ion and the sodium there is also a spectator ion. And if you remove those spectator ions, what you end up with is the reaction that is underneath. Okay, so once you've got this carboxylate ion here, so either the sodium propanoate or just the propanoate ion, it is possible to recover the carboxylic acid by adding a stronger acid. Okay, so just as an example with that one is if I was to add hydrochloric acid to this, and I'll do it underneath here, okay? So RCOONA. If I now add a strong acid to that, HCl for example, I'll get RCOOH. So that's the acid recovered, and then what's left over is NaCl. And it comes down to the fact that basically this strong acid here is a better proton donor, so it donates its proton to that. Okay, that's just a point to note really, that how we recover the acids from the salt of the acids when we do alkaline hydrolysis. So again, a few questions for you to have a go at and get back to me.